3, 2, 1.
Go! The weather today is gonna be great.
Hi, I'm Alexus
And Michaela.
Thank you for stopping by our channel.
Welcome to Alexus Explain, a series in which I'm asking Alexus questions about science.
And I do my best to answer them. In this first episode, the questions are going to be about
shooting stars, asteroids, and gravity.
I can't wait to hear them. Okay. No, because that's why they did this math. I'm a little bit confused now. Yeah, I feel like a news reporter. Watching the stars. What else are we doing? This is going well.
Last week when we were at the beach, having dinner, having a picnic,
Hanging out.
we were watching the stars, and we saw a giant shooting star. It was big.
It was big. And we both saw it.
Yeah, it was really bright, it was long, and I was thinking,
And wondered.
if we saw it where we were, did people like at the next beach over, did they see it too? Yeah, I don't know. I don't know science, so I'm asking Alexus.
So 2 people can see the same shooting star, but you have to be exactly no more than 2,240 kilometers apart.
Is that a lot?
Well, I don't know kilometers.
Okay, which countries are 2,000 kilometers apart? Wait, you can't be further apart than that? Or
Yeah.
you have to be exactly that?
No, you can't be further than
Can't
that.
be further than 2,200?
Yeah.
That's
1,391 miles.
1,300 miles.
That's a lot of miles. And that's assuming, okay, that the shooting star is between both of them.
Maybe you can look up how far is Germany from Hawaii. That doesn't make sense because they don't have the night sky when we do. So they can't see it, right? Can you see shooting stars during the day?
Depends on how big and how bright.
Easy.
Yeah.
This was a really big one. Maybe people saw it. What does it even look like during the day?
During the day?
Does it fly the same direction for them as for us? No. Because ours was definitely going from there to there.
From here to here.
Uh-huh.
No, I think theirs wouldn't be the same direction.
Where do they see it?
What do you mean?
You know, ours was like kind of...
Yeah.
Orion was here. It was like there. To the bottom left of Orion. Is that where they see it?
No, because like you don't see the same stars.
You see them differently.
Yeah.
Do you see them rotated?
Yeah, I guess it depends where. Like different hemispheres will have different skies, different stars.
Really?
The hemisphere thing?
Yeah.
Yeah. But if you're seeing stars towards the North Pole, you're not going to see them from like the South Pole.
Do people at the North Pole? I can't pronounce that word.
Pole?
North.
North.
No, it's together, I think. North Pole.
North Pole.
Do they see the same stars that we do? Some of them?
I think
only?
probably some of the same, but I think there's some that only we see and some that only they see.
Do we see the same stars in summer and winter? Or different?
I think, again, we see some of the same stars, but it changes with the seasons.
Crazy.
Yeah.
Do we see them differently during the night? Do they start out different than...
Like, does it change in the
8
course of
p.m.?
a night?
Yeah.
I don't know. Do stars move?
Okay, we move, right?
Yeah.
Right?
So they must, yeah.
And you can use stars for navigation, right?
Yeah.
Because once we saw the North Star in Waikiki,
Yeah.
and it was actually north.
Yeah.
Yeah.
Huh.
That's funny to think about.
Yeah, I think they do slightly change over the course of a night.
But then during winter, north isn't somewhere else. No, they can change.
But Earth's position changes.
Oh, maybe it's never like north exactly. North.
Yeah, that's why I'm saying I think
It's always in the direction of the North Pole.
yeah.
But it could be like there or there or there.
Say it again.
Because if it changes
If what changes?
the star where we see the North Star,
Yeah.
then that would mean the North Pole was somewhere else.
I don't know.
This is the end of Alexa's knowledge.
Yeah.
Are the spring rolls ready?
Not yet. So, the North Star is known to stay fixed. It marks the location of the sky's North Pole, the point around which the sky turns. That's why you can always use Polaris to find direction north. But the North Star does move. Oh, that's because the North Star is really offset a little by about 3/4 of a degree from celestial north.
What is celestial north?
Celestial north is the point in the sky about which all of the stars seen from the northern hemisphere rotate.
I need to think.
Yeah.
What?
Oh, weird.
You know, we never made one of those science things in class with like the planets on.
Solar system.
You know, with the like threads.
Yeah.
And all the planets on it.
Solar system.
Yes.
Yeah.
Yeah, I know the solar system. We just never like made one. I think that's why I don't understand now. So we should blame it on my science teacher.
The north and south celestial poles are the two imaginary points in the sky where Earth's axis of rotation, indefinitely extended, intersects the celestial sphere.
Okay, so this is Earth.
Mm-hmm.
It spins around this point, right?
It rotates, yeah.
Uh-huh. And that's why to us it seems like the stars rotate.
Yeah.
And they rotate around celestial north.
Yeah, I guess so.
Okay, what's up with celestial north now? Why did we need this? Is that the North Star?
No, I think the North Star is offset from celestial north.
It also moves around the celestial pole.
Yeah, it makes its own little circle
Around it.
around the North
Yeah.
Celestial Pole. That's why the North Star location does move, but it is always in the north. No, it makes sense.
Yeah, it does.
You have Earth, celestial north.
Okay.
Stars are going around. The North Star is also going around.
Uh-huh.
So the North Star
In a
is
tiny
changing
circle.
location, but it's always in the north, generally north.
Okay.
But it could be offset a little.
Okay, now back to our shooting star.
Back to the shooting star. I was just based on someone's math.
We can trust the internet.
It's because you can only see a shooting star a certain distance away, and let's say that distance is 1,000 kilometers or something.
Into the sky?
Away, yeah, away from you. What they did is like, there's you, there's me. I can see one 1,000 this way, you can see one 1,000 this way.
I see.
So 2 times one of our
Okay.
distance, assuming it's right in the middle. Then we can both see it. And that distance was like 22,000 kilometers.
So we can only see it when it's at least this far away, and
Not at least, at
Max.
max. Not that far away.
can it also if it's closer?
Yeah. Next question.
What are shooting stars?
I got this one. Shooting stars
This made it seem like we practiced this. We didn't.
are actually not even stars at all.
Yeah.
You know what they are?
What are stars? Planets and suns.
What?
What are stars?
Well, I'm going to tell you what a shooting star is first. Shooting star is not a star. Well, what is a star? No.
Yeah, that's what I'm asking.
A star is an astronomical object consisting of a luminous spheroid of plasma held together by its own gravity.
Okay, shooting star doesn't have gravity.
Well, I think it does. A star is a luminous ball of gas, mostly hydrogen and helium, held together by its own gravity. Okay? A shooting star is just like rocks or dust, just flying in space, and as Earth passes through it, it hits the atmosphere, and as it interacts with the atmosphere, that's when it lights up. So it's just a meteor.
A what?
A meteor. Shooting stars are meteors, and meteors are like smaller, the things that burn up and glow as it's passing through the atmosphere. And meteorites are larger, and those are the ones that land on Earth.
Shooting stars don't land on Earth.
No, they're too small. They like burn up and disintegrate.
I see.
But the bigger ones
Come to Earth.
come to Earth.
How often does that happen?
Meteors?
The ones that land on Earth. Meteorites.
Meteorites. Yeah, so shooting stars are common.
Are meteorites also shooting stars?
I don't know if they light up. Maybe they do.
In movies, they do.
Okay, about 15 per year.
15 meteorites land on Earth per year?
About 2/3 are found in the United States, in arid regions of California, Nevada, Arizona, New Mexico, Texas, and Kansas.
Why there?
It says they are very rare.
Doesn't sound that rare to me if it's 15. Are they the ones that make like craters?
Yeah. Well, I think
Not all of them.
maybe not all of them, yeah.
Okay. And shooting stars don't because they just dissolve.
Yeah, too small.
Where do the rocks come from?
Space. How do meteors form? Oh, duh. A collision of asteroids. As asteroids smash into each other, they produce crumbly debris called meteoroids.
Is that the big ones that land on Earth?
Meteoroids are different.
Okay, there's meteors, meteoroids,
Yeah.
meteorites. That
Yeah.
was the same word that I just said.
So when meteoroids enter Earth's atmosphere at a high speed and burn up, the fireballs or shooting stars are called meteors. When a meteoroid survives a trip through the atmosphere and hits the ground, then it's called a meteorite.
I see. That's the group label.
Yeah.
Okay. And they form with asteroids.
Asteroids smashing into each other and
Where do
crumbling.
asteroids come from?
Space? Asteroids are left over from the formation of our solar system. So, you know, a solar system.
From the formation of it? They're old then.
Yeah. Oh my gosh. This is cool.
Okay.
Dust particles in the early solar system collided, forming larger clumps, known as planetesimals. These could grow by attracting more dust with their gravitational fields, and some grew large enough to form planets. Others remained, becoming asteroids. That's cool. So they're formed by dust.
There.
Mm-hmm.
Like when you do this with sand.
Yeah, same thing. Just
Or frikadellen.
what?
Meatballs.
Meatballs.
How do they stick together? Gravity.
Gravity's holding it together.
How did gravity come? Where does gravity come
Well,
from?
don't all things have gravity? Things with mass have gravity, right? How did planets get gravity? Planets have gravity, but what is gravity and where does it come from? To be honest, we're not entirely sure.
Then I forgive you for not knowing. Maybe see if asteroids have gravity.
Asteroids without artificial gravity have relatively little gravity in comparison to Earth.
What the heck is artificial gravity?
I don't know. Gravity is a result of mass.
A result of? What
Yeah.
doesn't have math?
Mass? Mass. So any body with a non-zero mass will have a gravitational field associated to it. Okay, so I think they have gravity, but because they're tiny compared to Earth, they have relatively little gravity because Earth's gravitational field is so much greater.
Okay.
Thing.
Everything has gravity?
Yeah.
The chair? That's a table.
Do tables have gravitational pull? Yes, two objects on a table or two objects floating in space. In fact, every two objects in the universe are being pulled towards one another by a gravitational force.
Really?
As long as both objects have mass.
And just because Earth is so big, everything gets pulled towards Earth?
Yeah, I think so.
What about like a really big building? Does everything get pulled towards the building? No.
No, I think because everything's still getting pulled towards Earth.
Earth. Okay, what about the ISS? People are still floating in it. It's pretty big. Is it big? Probably not. Why are they not being pulled towards the ISS?
Why is there no gravity in the ISS?
And why didn't you look up this question before this?
Didn't think about it. Is there gravity on ISS? The gravitational field on the ISS is approximately 89% of that on Earth's surface.
That's a lot.
Does the ISS have Wi-Fi? Yes. Oh. Okay. So why do astronauts aboard the ISS seem to float? It's only about 200 miles above Earth, where according to Newton, gravity is almost as strong as it is here on the ground. But they experience weightlessness not because of lack of gravity, but because the ISS and they are orbiting Earth in a constant free fall. Oh, and if you're in a free fall, there's no gravity.
Why are they in a free fall?
They're falling toward the Earth and moving forward at about the same velocity. Because the downward and forward forces are nearly equal, they're not pulled in any direction, so they float. So it's not that there's no gravity.
They're falling down and at the same time going up?
Yeah, like the forces in opposite directions are equal, so they just balance out.
Do they feel like in a free fall?
I hope
No.
not. No.
That's scary.
Yeah.
I thought it was just no gravity.
No gravity. That's kind of what I thought.
Wild.
Wild. Come on. I got all your answers.
You do. You're smart.
Mm-hmm.
If you ever want to know anything, Ask Alexus.
Ask Alexus. It is commonly believed that Earth is perfectly spherical, but in reality, it is an oblate spheroid with varied geographies contributing to the uneven distribution of mass on the surface of the Earth. Due to its uneven distribution, Earth wobbles as it spins on its axis.
Oh. Gravity's not the same everywhere? Because sometimes we're closer to the middle.
What do you mean?
You know, if it was completely round, we were the same distance from
the middle.
From the middle. Oh, but it's not. So some people are closer. Yeah, but that's also if you're on a mountain. Is gravity less on a mountain?
With altitude.
Yeah.
Yeah. I know it's less pressure. Yeah, a person standing on the Earth's surface feels less gravity when the elevation is higher.
Crazy.
Yeah. Oh, so if you measure gravity by a scale and a weight, things weigh more on top of a mountain.
I thought less.
Because of thinner air, even though, the gravitational force is slightly lower.
Oh, because of thinner air?
Yeah.
What does that have to do with it?
Due to loss of air buoyancy, maybe you float less.
You get heavier.
Yeah.
Huh. Let us know in the comments if we're wrong. We talked about stars, about shooting stars. I learned. Already forgot everything.
We talked about meteoroids, meteors, meteorites, asteroids, stars. Asteroids are really old. Who knew?
Everything has gravity.
Everything has gravity as long as it has
Mass.
non-zero mass, yeah.
And the ISS doesn't float because of no gravity. It floats because it's in free fall. And people did see or could see the same shooting stars. You know, I think you can probably see a shooting star if you're like right below it. You can see it like 1,100 kilometers in one side and 1,100 kilometers to the other side.
If you're right below it.
And if you're 1,100 kilometers apart, the other person can also be 1,100 kilometers apart.
Yeah, I think that's what I was trying to explain.
Yeah, I'm just stupid and only just now got it. Okay.
Yeah,
if
we
we
should
were
be
on the
able to
east
see
side,
Yeah.
people in Waikiki can still see it.
Yeah.
Okay, and they can see the same stars. And everyone in the northern hemisphere can kind of see the same stars.
Yeah.
And
People towards the poles see different stars.
they can probably see the North Star going like this.
Yeah, imagine.
Huh.
Wow.
That's a lot to think about.
That is a lot.
Thanks for explaining it to me.
You're welcome. I hope you learned something.
I did.
Katie, what did you learn?
What did you expect?
Nothing. Okay, I think that's it.
Okay, let's see if we can observe what we learned.
Ready, Big Dipper?
I didn't see a dipper. Orion.
Yep.
This is where we saw the shooting star.
Shooting star.
It's a meteor and meteoroid. A little dipper. I see it all the time.
I feel like it's right north of it.
Yeah, I see it. Sirius.
Sirius. The brightest.
The brightest star. Can we see the North Star? It should be somewhere there, right?
North isn't it that way? No, we're kind of
North Shore.
west. Yeah, we're that way. Yeah, it could be that one actually.
Some of these could be planets, right?
Some are planets, yeah. Sky scanning. That was cool. No,
Skyview light.
Sky view light.
Download the app.
Down. It's drums.
That's pretty.
It is really pretty. So that star kind of looks reddish to me. The one kind of off by itself.
This one.
Yeah.
Yeah, those both of them.
Yeah. This one looks more red.
Yeah, maybe it is this one then.
Close your eyes.
Last week we were at the beach.
Yeah, it wasn't a date.
I should be an actor.
Cut. Last week.
They're pretty.